Let's look at what the quadratic formula is and when we use it. There are two methods we've learned in this course so far. The first is the square root method. And we use this method when an equation is in standard form where b is 0, meaning we have no linear term. So something like 4x squared minus 8 equals 0. There's no plain old x. Or if something's in vertex form, something like 4 times the quantity of x minus 5 squared equals 7. This could be solved with the square root method. Then we learned factoring in the zero product property. This method is sometimes a little harder to spot at the beginning. We can do this when the equation is factorable. But spotting a factorable equation can be a little tricky. So sometimes it's just after trial and error that you abort on this method. Our third method we're going to talk about in this course is the quadratic formula. This method always works. It's got something that looks like kind of a nasty formula, but it's not hard to memorize, and it's awesome because it always works. You begin by identifying the values of a, b, and c, and then the quadratic formula is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Let me show you how it works. So here I have a quadratic equation, so I'm going to go to the quadratic formula, but first, to identify a, b, and c, my equation has to be in standard form. So x squared minus 2x minus 15 equals 0. Next, I identify the values of a, b, and c off on the side. So a is 1, b is negative 2, and c is negative 15. Until you get really good at it, I suggest you write down the formula over and over. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And now it's a matter of substituting properly. Negative b is also read as the opposite of b. So you take this and you flip its sign. So it's positive 2 plus or minus the square root. Out of habit, always stick the b in parentheses. Right? So we're going to do b is negative 2 minus 4 times a is 1, c is negative 15, all over big fraction bar 2 times a. Now let's clean it up. So I'm going to put this into my calculator. Negative 2 squared is positive 4. If you drop your parentheses, you're going to get negative 2. It should be positive 4 minus 4 times 1 times negative 15 gives me positive 60. So I'm going to 4 plus 60 is 64 for my Radicand. But again, just stick that whole part known as the Radicand, this part I'm highlighting, without the square root in your calculator, and you get 64. I'll recopy the rest. 2 plus or minus root 64 over 2. Now let's start cleaning this up. Square root of 64, we know that's 8. So I'm going to have 2 plus or minus 8 all over 2. Now again, that plus or minus sign means that our one answer is 2 plus 8 over 2. Our other one is 2 minus 8 all over 2. We can clean that up. 2 plus 8 is 10. Divided by 2 is x equals 5. Or x equals 2 minus 8 is negative 6. And negative 6 over 2 is negative 3. So here are my two solutions. Remember that this is where it crosses the x-axis. So this is your x-intercepts or your roots. Let's do another practice question. So again, it's quadratic. I'm going to jump right into the quadratic formula because I know it's going to work. Definitely couldn't do vertex form here because there's a linear term. So I'm going to put it in standard by subtracting 9 from each side, which gives me 3x squared plus 5x plus 1 equals 0. I guess it could possibly factor. But again, quadratic formula, identify the value of a, b, and c would be 3, 5, and 1. Again, until you get really good at this, practice writing the quadratic formula to help you learn it. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we begin substituting. The opposite of b would be negative 5 plus or minus the square root of b squared minus 4, I'm going to open up some parentheses, times a times c, all over 2 times a. Let's substitute. b is 5, minus 4 times 3 times c would be 1. And on the bottom, 2a would be 2 times 3. Now, multiply or simplify what's under the radical sign. That's known as your radicand. So in other words, this part right here, toss that in your calculator. 5 squared is 25 minus 12 would be 13. So I get negative 5 plus or minus root 13 over 6. This means that there are 2 answers, okay? But things you should do, check this. Root 13, is that going to break down? Nope, 13's prime, so that's not going to simplify. So you can write this a couple of ways. This would be my exact answer. I would accept it like that. The other way is to break it up the same way we do complex numbers, like negative 5 6 plus coefficient here would be 1. So 1/6 root 13 would be the other way. Or, remember there are 2 answers, negative 5 6 minus 1/6 root 13. So I would accept either scenario here. Okay, either one. If you're asked for a decimal answer, that means you have got to type it into your calculator. And I will tell you, some kids struggle getting this in the calculator. When you do it, you make sure you have the top, negative 5 plus root 13. You may need to add parentheses, /6, and then you do negative 5 minus root 13, close your parentheses, /6. And there are my 2 answers to the nearest hundredth. Okay, so my parabola would cross at negative 4.3 and negative 0.23. All right, again, find the x-intercepts. So it's asking x-intercepts, but again, that's just another way of saying the solutions. We just need to solve this. So I'm going to put it in standard form. I'm going to bring everything over to the left. So I'm subtracting 12x and I'm adding 9 to produce 25. X squared. I'm going to be subtracting 12x. That's going to make that be negative 30x. I'm going to add 9 and be plus 9 equals 0. Standard form, so I identify a, b, and c. It would be 25, negative 30, and positive 9. So again, until you get good, do it a couple of times. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Go ahead and substitute. Notice again, this is positive 30 because it's the opposite of b. I have a set of parentheses so I can square b and not drop my sign. So I plug in negative 30, 25, c is 9, a is 25. Pause and double check that you have your substituting right, because there's nothing worse than going through these big long problems and realizing you substituted the wrong value. So now find the value of the radicand, the value under the house. And I get 0 when I do that. 0 over 50. Now, that's actually kind of nice, because what's the square root of 0? It's 0. Give myself a little more space to write. So I have x equals 30 plus or minus 0 over 50. Well, adding 0 or subtracting 0 leaves me with just 30 over 50, which reduces to 3/5. So this has just one solution, which if you think about, well, how is that possible if we're talking about x-intercepts? This would be a scenario where the parabola just kind of the vertex sits right on the x-axis at 3/5. In my fourth and final example, something funny is going to happen here. Now, I have told you before, I hate when my leading coefficient is a negative value, so I'm going to bring it to the right so that it switches to positive. It is just my personal preference. I find I make fewer mistakes when I do that. So I'm adding x squared and I'm subtracting 4x from each side. which produces 0 equals x squared minus 4x plus 5. So off on the side again, I'm going to identify the values of a, b, and c. 1, -4, and 5. The quadratic formula is -b plus or minus the square root b squared minus 4ac all over 2a. Start plugging in. Opposite of b would be 4. Plus or minus the square root, open parentheses, minus 4 times a times c. B is again -4, a is 1, 5 for c, all over 2 times 5. So 4 plus or minus, clean up the value of the radicand. Figure out this, -4 squared is 16, minus 20. 16 minus 20 is -4. So I'm going to have the square root of -4, and that right there is going to tell you that we're dealing with an imaginary number, even a complex number because part of it's real here. Okay, so that square root of -4 at this stage of Algebra 2, you should recognize that as equal to 2i. Give myself some more space again. Right, so the square root of -4 is 2i. So I have x equals 4 plus or minus 2i over -2. If you can get it to that point, that's pretty awesome. We can clean this up just a little bit. We can reduce by doing 4 over -2 plus or minus 2 over -2i, which would be x equals -2 plus or minus 1i. Now, sometimes kids say to me, wait, where did that should be a positive divided by a negative is a negative? And you're not wrong, but neither am I if you look at what's below, because if you think about what's actually happening, just to show you off on the left here, that's the same as -2 plus or minus -1i. Well, what's my one solution? That means it's -2 plus -1i, which would clean up to -2 minus i. The other one would be -2 minus -1i, and this would clean up to -2 plus i. So I'm showing you that, isn't that exactly what I have right here? So I'll take it either way, of course. All right, so complex solutions. There's 2 of them. How do I have complex solutions? Well, what's that mean? That means if we were to graph this, it never crosses through the x-axis. The parabola either hovers above or below. So this is definitely a concept that you need to practice. It's really easy to make tedious little mistakes. Start by over and over learning that quadratic formula. Sing the song as I suggested in class.